So this is HESI Chemistry video number 3. We're still talking about elements and atoms, and now we're going to talk about how to calculate the atomic mass. So quick review of what we've been talking about, protons, neutrons, and electrons. Protons have a mass of 1, charge of 1, and they live here in the nucleus in the center. Neutrons also have a mass of 1, but their charge is 0. And they live also in the nucleus with the protons. The electrons are itty bitty, teeny tiny. We consider their mass to be 0. They have a charge of -1, and they live outside the nucleus in these areas that are known as electron clouds, shells, or orbitals. And in the last video, we talked about the atomic number and that it is exactly equal to the number of protons in a particular atom. So if we count up the protons, 1, 2, 3, 4, 5, that means the atomic number of this atom model is 5, and it also means that the identity of the atom, what element this is based on only the number of protons. So in this case, with an atomic number of 5, we have a model of boron here. So moving on now to the atomic mass. The atomic mass is a very simple equation also. It is the protons plus the neutrons. So sometimes you'll be told how many electrons are there, and you need to remember that you don't use that number anywhere. So I'm going to cross it out here. So 5 protons, 6 neutrons, and if it had 2 electrons, we'll put them there just so you remember that whether they're there or not, you don't count them in the atomic mass. So we're just going to count up everything that is in the nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 things in the nucleus, 11 protons and neutrons, and that is the atomic mass. And if we just want to do it using the equation, the atomic mass is 5 protons plus 6 neutrons, and that gives you 11 for the atomic mass. So just some simple addition. Sometimes the questions are worded differently. If they told you, for example, that your atomic mass was 13, and they either told you that you have 7 protons or that your atomic number is 7, which is 2 different ways of saying the same thing. If the atomic number is 7, then you have to have 7 protons. And then they ask you how many neutrons you have. You can still calculate that using the equation or by drawing out a model. So I'm going to take out the electrons because A, they don't tell us how many electrons there are in this particular problem, and also because, as I mentioned, the electrons don't matter if we're calculating atomic mass. And since we don't know how many neutrons we have, taking them out, and then we have to start with the right number of protons, which is 7. So we had 5 in there, that makes 6, 7. So how many neutrons do we need to add to this to just get a total of 13 things in the nucleus? So we start with 7, and now we have 8, 9, 10, 11, 12, 13. Okay, so now we're at our atomic mass of 13. How many neutrons did we have to add to get there? 1, 2, 3, 4, 5, 6. So that means there are 6 neutrons in this atom. To get there using the equation, you'd plug in 13 for the atomic mass, 7 for the number of proteins, and then solve for the unknown number of neutrons. So then we'd need to subtract 7 from both sides, which would give us 6, and of course, same answer, 6 neutrons. Sometimes the numbers are a lot larger and you might not want to draw a model of an atom with an atomic mass of 54 and 29 neutrons. In that case, you're better off just plugging everything into the equation. So in this case, it says, what is the atomic number? Atomic number is not in our equation, but we do know that protons and atomic number are the same thing. So we'll solve for the protons, and then that's also going to be the atomic number. So we'll take the calculator. It's going to be a very simple calculator that you have, what they call just a 4-function calculator. Will have the numbers, plus, minus, times, divided by, equal sign. It probably will not have a percent or a plus minus button, and then that's just the clear button. You'll have something like that. So if we plug this into our equation, atomic mass is protons plus neutrons, then we've got 54 equals unknown number of protons plus 29 neutrons. So we're going to subtract 29 from both sides. So 54 minus 29, and that gives us 25. So if we have 25 protons, then our atomic number is 25. Another reminder, I mentioned this earlier, but you will sometimes be given the number of electrons, and you have to remember to ignore that. If you're given them and you're asked for the atomic mass, then please don't fall into the trap of adding the protons, neutrons, and electrons. So in this case, that would give you 16. If you added them all up, it's a multiple choice test. I can guarantee you that 16 is going to be one of the answer choices, but it's wrong. Don't do it. So again, as a reminder, I'm going to cross out the electrons and then plug into the equation for atomic mass. 5 protons, 6 neutrons is 11. And another example here, last example that we're going to do for atomic mass right now, is if you're given the atomic mass is 108, there's 47 protons, 46 electrons, and it wants to know how many neutrons. Cross out. You can't really cross it out because it's going to be on the computer. Ignore how many electrons they give you. Do not use that in your calculation anywhere if they're asking for atomic mass. Just grab your handy dandy calculator, plug it into your equation. The atomic mass, 108, equals 47 protons plus unknown number of neutrons. So 108, and then we're going to subtract 47 from both sides, and that gives us 61 neutrons.